In this video, we'll solve another elastic collision problem. In this case, though, both blocks are moving. Now, I know, we've done in the previous video, we did one where, one of the blocks was not moving. But, what if both of them are moving? Okay, the concept is basically the same. You just have to be careful with your algebra. Just do everything, work everything out properly, and we'll go ahead and do this. Okay, so we've been told that the collision is elastic, so that allows us to use both momentum conservation and kinetic energy conservation. Alright, so let's use Pi equals Pf first, and let's set up our equation. Okay, so using this, we have 2 times 5 for the momentum in the beginning, plus 3 times minus 4. Remember, the 4 is moving, the 3 kg block is moving to the left in the beginning, so we have to account for the negative sign, and that is equal to 2 times V1 plus 3 times V2. Okay, so we can put an F there. And I can simplify this, and I get a 10 and minus 12, you get minus 2, so I get 2 V1 final plus 3 V2 final is equal to negative 2. Alright, great. So we have one equation. Let us set up the kinetic energy equation now. And what do we have? We have KEI equals KEF, and what we have is 1/2 times 2 times 5 square plus 1/2 times 3 times 4 square is equal to 1/2 times 2 times V1F square plus 1/2 times 3 times V2F square. And once again, what we'll do is we'll get rid of all the halves. So half, 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 half goes away. Just get rid of it so that you don't have to deal with unnecessary decimal places. Oops. Okay, there we go. Okay, and then what we do is we have 2 times 25, which is 50. So we have 50 plus 16 times 3 is 48. So 48, and this is equal to 2 V1F square plus 3 V2F square. So I have 2 V1F square plus 3 V2F square is equal to 98. Alright, great. We have two equations. Okay, so this is my equation 2, and I have my equation 1, which says what is it? Yeah, 2V1F plus 3V2F is equal to minus 2. Great. So now we're in business. What we'll do is we'll solve for V1F from equation 1. So equation 1 implies that V1F equals what is it? Negative 2 minus 3 V2F divided by 2. Okay, so let's minus 2 minus 3 V2 divided by 2. Okay, great. So we get this. Now what we'll do is we'll substitute this into the second equation. So we'll take this equation and substitute for V1F. So it gives us 2 times minus 2 minus 3 V2F over 2 the whole square plus 3 V2F square is equal to 98. Right. Let us simplify everything. So now this implies the following. We have so first the 2 comes out. Okay, what we'll do is just factor it out. We know that a plus b the whole square is equal to a squared plus 2ab plus b squared. You see the negative sign here, it will simply cancel out. We'll end up getting 4, which is the square of 2, plus 2 times 3. So 2 times 3 is 6, times 2 is 12 v2f plus 9 v2f squared divided by 4 plus 3 v2f squared is equal to 98. Great. Now what are we going to do? Let's we can divide by 2, and what we end up getting is 4 plus 12 v2f plus 9 v2f squared all over 2 plus 3 v2f squared is equal to 98. Alright, let's do this. Let's multiply both sides. Let's multiply everything by 2, and I get 4 plus 12 v2f plus 9 v2f square plus 6 v2f square is equal to 196. Great. Okay, now let's combine the terms. We're going to combine v2f square and this v2f square, so it gives us 15 v2f square plus 12 v2f minus 196 minus 4 is equal to 192, and all this is equal to 0. Great. Okay, so now we can factor this out using quadratic equation. So what we have is we have our solutions, which are v2f is equal to minus b, which is minus 12, plus or minus square root of 12 square minus 4 times 15 times negative 192, and all that divided by 2 times 15. Great, let's do this. So 12 plus or minus square root of 144 plus 4 times 15 is 60, and you have 192, which is 11520. Okay, all this divided by 30. Okay, and that gives us minus 12 plus or minus square root of 11664, all divided by 30. And as we all know, the square root of 11664 is nothing but 108 divided by 30. Right. And what we have now is we have two answers. We have negative 12, negative 108, which is negative 120 divided by 30, or we have negative 12 plus 108, which makes us 96 divided by 30. Right. So we have minus 4 meters per second for V2, or V2 is equal to 96 over 30, which is nothing but 9.6 over 30, so it is 3.2 meters per second. Great. So V2 equals this, or V2 equals this. Now if V2 is equal to negative 4, then V1 is equal to negative 2 minus 3 times minus 4 divided by 2, and this, if you calculate carefully, ends up being, so 3 times 4 is 12, 12 minus 10 is equal to 5 meters per second, or V2 equals negative 2 minus 3 times 3.2 divided by 2, and this happens to be minus 2 minus 3 times 3.2 is 9.6 over 2, so 11.6 over 2 is equal to negative 5.8 meters per second. Now, as you may have recognized, that the first set of answers, which is this negative 4, negative 5, is nothing but the initial condition. This is how it all started, 4 and negative 4 and 5. This is the initial condition. So this, we are not interested. This just says that, hey, either this is just the initial condition or that there was no collision, okay, which is uninteresting. So the interesting answer is this, the 3.2 and the negative 5.8. Okay, so that's it for an elastic collision where both blocks are moving.